Right now, somewhere in the empty space around you, there could be a particle passing through your body every second, one that has never once collided with a single atom of you, and it has been doing this since before you were born. But what's even crazier is that this particle, if it exists at all, might outnumber every atom in your body by a factor of 1 billion. Nobody has ever seen it. Nobody has ever touched it. And yet without it, galaxies would tear themselves apart, stars would never have formed, and you would not be here to hear this sentence. This is dark matter. We cannot see it. We cannot photograph it. All we have are its footprints, scattered across the universe, like something walked through reality and left no body behind, only weight. Tonight, we are going to rank the 10 leading answers to the question every physicist on Earth is desperate to solve. From the most boring explanation to the one so strange it barely resembles matter at all. Candidate number 1 is the simplest and the least exciting. Rogue planets and dead stars, drifting through the galaxy with no light of their own. Astronomers call them MACOs, massive compact halo objects, and for decades this was the leading theory. Take every object too dim to see. Black dwarfs, brown dwarfs, wandering worlds with no sun to orbit, and stack enough of them together, and maybe that explains the missing mass. It seems like the obvious answer, the boring answer, the one that requires no new physics at all. But here is the problem. When astronomers searched for these dark objects using gravitational lensing, watching for their gravity to bend light from stars behind them, they found nowhere near enough. Candidate number 1 is real. It is nowhere close to enough. So if dead stars and rogue planets cannot account for it, the next candidate had to be something invisible by nature, not by distance. Candidate number 2 takes us into the world of particles smaller than atoms. WIMPs, or weakly interacting massive particles, are hypothetical particles that would barely interact with normal matter at all, slipping through planets and people alike. Picture a particle heavier than a proton, but so antisocial that it can pass through the entire Earth without slowing down. For 30 years, this was physics' best guess, and billions of dollars were spent building detectors deep underground, shielded from cosmic noise, waiting for a single WIMP to bump into a single atom. Here is the strange part. The very property that makes WIMPs a good explanation, their near-total refusal to interact, is the same property that makes them almost impossible to prove exist. We built machines to catch a ghost designed never to be caught, and if the ghosts refuse to show themselves, maybe the problem is not the detectors. Maybe the problem is what we are looking for. Candidate number 3 shrinks the ghost down to something almost too small to imagine. Axions are theoretical particles, so light, that trillions of them could occupy the space of a single atom without conflict. They were not even invented to explain dark matter originally. They were proposed to fix an unrelated puzzle in nuclear physics, and only later did scientists realize their properties matched perfectly with what dark matter would need to be. This is where things become strange. A particle invented to solve one problem might, by accident, be the answer to an entirely different one. The hidden ingredient the equations seem to require in order for reality itself to function. Experiments are hunting for axions right now, using magnetic fields to try to catch them, converting into detectable light. So far, silence. But the next candidate does not stay small. It goes in the opposite direction entirely. Candidate number 4 asks a darker question. What if dark matter is not a new particle at all, but something we already know, just born in a place we cannot see? Primordial black holes, if they exist, would have formed in the first fraction of a second after the beginning of the universe, long before stars, long before galaxies, from tiny fluctuations in the density of the newborn cosmos. Some could be smaller than an atom, and still weigh as much as a mountain. Others could be scattered across galaxies in numbers too vast to count. It sounds like the perfect explanation: mass without light, gravity without a surface to see. But when scientists searched for the gravitational lensing signature these black holes should produce, the numbers came back too low to account for everything missing. Candidate number 4 might exist. It is simply not enough. If no single explanation accounts for all of it, the next idea asks whether dark matter might not be one thing at all. Candidate number 5 is self-interacting dark matter, a version of the ghost that does not ignore itself completely. In this model, dark matter particles rarely interact with normal matter, but they might interact with each other, colliding and scattering in ways that shape how galaxies form. This one seems, at first, like a minor technical adjustment, but the deeper implication is unsettling. It suggests there could be an entire hidden sector of physics running parallel to our own, with its own particles, its own forces, its own rules, and we would never know, because none of it touches the world we can see. Somewhere out there could be a shadow version of chemistry we will never observe. If you have made it this far into the search for the universe's missing mass, drop a like and subscribe, because the next candidate does not just bend our theories, it bends the fabric of space itself. Candidate number 6 throws out the particle altogether. Modified Newtonian dynamics, or MOND, proposes that dark matter does not exist as a substance at all. Instead, our understanding of gravity itself breaks down at galactic scales, and what looks like missing mass is really just gravity behaving differently than Newton or Einstein predicted. It is an elegant idea. No invisible particles required, just a correction to an equation. But here is where the illusion collapses. MOND explains individual galaxies beautifully, and then fails almost completely when applied to galaxy clusters and the largest structures in the universe. A theory that fits one scale and shatters at the next is not a solution. And if gravity itself is not the answer, the next candidate suggests the universe may be hiding an entire mirror world. Candidate number 7 is mirror matter, a theoretical form of matter that would have its own version of protons, electrons, and atoms, built from particles that interact with gravity, but almost nothing else we know. Imagine an entire shadow universe, stars, structures, possibly worlds, existing in the same space as our own. Invisible, not because it is far away, but because it simply does not touch light the way we do. It sounds like science fiction, but the equations that allow for it are not fiction. They are simply unconfirmed. No mirror world, no mirror stars, no mirror light, just a hypothesis quietly sitting in the mathematics, waiting for proof that may never come. The next candidate takes that same idea and gives it something almost personal, a force of its own. Candidate number 8 is dark photons, a hypothetical dark counterpart to the particle of light itself. If dark matter particles exist, some physicists believe they could carry their own force, mediated by these dark photons, allowing dark matter to interact with itself in ways ordinary matter cannot detect. Picture two ships passing in open water, invisible to each other except for the wake they leave behind. That wake is gravity. Everything else stays hidden. Experiments are now being built specifically to search for dark photons, hunting for the faintest possible link between our world and whatever this one might be. But what happens if dark matter is not particle-like at all? Not something you could ever count one at a time. Candidate number 9 is fuzzy dark matter, built from particles so unimaginably light that they stop behaving like tiny points and start behaving like waves stretched across enormous distances. In this model, dark matter is not made of countless individual specks scattered through a galaxy. It is closer to a single, smeared-out quantum wave, large enough to wrap around an entire galactic halo. This is where the illusion truly breaks. Something we picture as matter, solid, countable, particle by particle, may not be made of particles behaving like particles at all. It may be closer to a standing wave, the size of a galaxy, silent, invisible, and holding everything together anyway, like a lion sleeping at the center of every galaxy in the sky, unseen but never absent. And that leaves us with the final candidate, the one that does not just challenge what dark matter is, but whether the question itself has been asked correctly from the start. Candidate number 10 is the possibility that dark matter is not one substance, one particle, or one wave, but an entire unseen sector of the universe, layered with its own physics, its own history, and its own structures we may never directly perceive, connected to our world by nothing but gravity, not a ghost, not a shadow, a second architecture running underneath everything we call reality, present in every galaxy, every cluster, every corner of the observable universe, and utterly undetectable except through its pull. We have never confirmed it, and we may never confirm it, but the evidence for its presence is now overwhelming. 90% of the mass of the universe may belong to something we cannot see, cannot touch, and cannot yet name. If you made it through all 10 candidates for the most abundant substance in the universe, subscribe before the next hidden sector of reality gets discovered without you. And if you are not ready to go back to normal space just yet, the next video on this channel goes even further into the unseen architecture holding the cosmos together.